Okay, so we're going to continue talking about one-step equations, talking about adding, subtracting, just like we did yesterday. So addition and subtraction are inverse operations. And by that, what it means is to undo, so now if you're looking down here, to undo addition, use subtraction, and to undo subtraction, we use addition. The main point I want to get here is to always get your variable by itself. You want your variable to be totally alone so you can find out what it is. So we'll go through 3 examples. So to start with example 1, if we have a minus 6 equals 13. Okay. So our goal is to get this a completely alone. So like it said above, to undo subtraction, you can use addition. Or if you want to think of it as this is a negative 6, so to undo a negative 6, you should add 6. So we're going to have a, minus 6 plus 6 equals, and like when we were talking about that scale, we always want our scale to be even. So since we added 6 to this side, we also need to add 6 to this side. So we're going to have 13 plus 6. So if you look here, we added this 6 over here, and we're adding this 6 over here. So when we have a negative 6 plus 6, that's going to cancel out to leave us 0. So we're going to be left with a on this side equals, and over here we have 13 plus 6. Okay, well, they're both positive, so I'm just going to add. So 13 plus 6 would be 19. So a equals 19. Now, one thing I always want you to do is I always want you to go back and check your answers. So we're going to go ahead and we're going to plug this 19 back in for a. So if we take 19 minus 6, is it 13? And our answer is correct. So our answer is a equals 19. Okay, example 2. We have 9 plus m equals 10. Now sometimes it helps to think about these numbers if it's positive or negative, because like in our last one, it was a lot easier because the variable was first, so it was a lot easier to think about. So for this one, to get rid of this 9, we're going to need to subtract 9. Or if you want to think about it, this is a positive 9, so we need to use a negative 9 to get rid of it. So we're going to have 9 minus 9 plus m equals, since we subtracted 9 on this side, we have to think of our scale. We also have to subtract 9 on this side over here. So we're going to have 10 minus 9 on this side. So our 2 things we just added in are right here and right here. So when we take 9 minus 9, we're left with 0. So on this side, we just have m equals, and when we take 10 minus 9, we have 1. All right, to check it, can't forget to check it, we're going to go ahead and we're going to plug it back in. So if I have 9 plus 1 equals 10. Does 9 plus 1 equal 10? Yes. Good. All right, our last example, example 3. Oops. Whoa. Sorry about that. So for example 3, we have r minus 20 equals a negative 60. So if you can think about it 2 ways. If you want to get rid of this subtraction, you need to use addition. If you want to get rid of this negative, you need to use a positive. So we're going to have r minus 20 plus 20 equals negative 60. And again, with our scale, whatever we do to this side, so we added 20 to this side, we also have to do to this side. So we're going to add 20 over here. So these 2 are going to cancel each other out. I'm going to be left with r on this side equals, if I have a negative 60 and a plus 20. So they're different signs, so I'm going to subtract. So I'm going to take 60 minus 20 is going to be 40. And then since my bigger number is 60, I know it's going to be negative. So my answer is r equals negative 40. So if I go to plug that back in, I'll have negative 40 minus 20 equals 60. So if I keep change, negative 40 and negative 20, those are the same sign, so I'm going to add, oh, sorry, negative 60. I'm going to add, and 40 plus 20 is indeed 60, and it should be negative because they're going to be you keep the sign. So negative 60 equals negative 60, and our answer checked out. Thank you for listening.